Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, I'll help get you started with Class 15 on correlation and categorical contingency tables applied to your project. I'm going to scroll down to the timetable, Class 15, and there's no markdown file here, so that means that this is part of your project. If I page up for a moment, recall that is in your outline file. In fact, we can very quickly take a look at that rubric. If I search in this document, Control F, Class 15, and click on this link, we have two goals. The first is to use basically just to calculate and interpret a correlation. Okay, so correlation is defined for two numeric variables. You have recently looked at a numeric variable and done logarithmic transformations on the variables and chosen a scale that works very well for a bivariate relationship. That's probably a good place to start for this. So go ahead and maybe grab that plot and you can repeat it here and then calculate the correlation and interpret it. The second part is to either choose 2 or 3 variables. I'm going to show a 3-variable example, but there's no need to do that. You can do 2 variables and just look at a categorical plot, calculate the conditional proportions, and interpret those results. So you get points for providing a frequency table with the proportions calculated and then plotting those proportions. These are all the things that we did in the last assignment. And then interpret the relationships that you see between the proportions. And there are sections or space down here for doing the work with the correlation and then doing the interpretation, and same thing for a contingency table and its interpretation. So because this is a continuation of the previous assignment, I'm going to start up our studio and open up the project file from last time and continue. So let's see, here it is here. So first thing to do always, well at least I recommend, is save this as with a new file name. I do mine based on the dates, and set the working directory to the source file location so that any work we do in the console will know where to find the data files, and then knit the document to know that we're starting with a document that knits, that everything works inside of it. Alright, so while that's knitting down in the markdown area, let's search for class 15 to jump down in my document to around line 1500 and find the rubric that we just looked at, and then we've got the correlation section and the contingency table section. Alright, so let's start on the correlation section. On the last assignment, in a recent assignment with log transformations, we found a bivariate relationship that we liked and plotted that and decided what scale to use those variables in. Let's scroll up and use that relationship here. So I'm going to scroll up. Let's see, we're just reminding me 1560 is the line number. I'm going to page up here, and I believe in my previous, this is the log. Is that right? Yes, these are the log variables here. I liked, oh, you know what? I did 2 of those. Okay, what happened to your data when you transformed it? I preferred choose the best scale. I chose log y on my previous, on my log assignment. So I'm going to choose the plot that has log y, that's right here, and bring that down to our area below. Okay, here is, it just finished knitting. Here's that area. I'm going to insert a code chunk and paste that plot in here. So that's a good place to start. The other thing is, in that previous assignment, when we, well, there was a logarithm assignment where, well, let's just go find it. There was an in-class assignment for logarithm. Here it is. And in that assignment, we mutated and created a new variable on the log2 scale. I want to do that also for this for this variable, because we've got totals so for my example, we've got age and total cigarettes smoked, but we wanted total cigarettes smoked, that y variable right here, right? So the aesthetic here, let me make this a little wider. Oh, not quite wide enough. Right, the aesthetic here, y equals total cigarettes smoked, and that's what we used in ggplot. We did the scale y transformation, but we don't have that variable in our data set. So I'm going to create a new variable that is on the log2 scale. All right, I just decided to run all the code chunks above so that we'll have all the data in our environment. But let's scroll up to where we create new variables. This might be a little hard to find just by paging up on such a small screen. Okay, but I think we're getting close. Here's some from many categories to a few, numeric. Here is where I created the variables total cigarettes smoked. It was the number of days you smoked times the number of cigarettes you smoke per day. So this is a good place to create this new variable. In fact, gosh, I should just add it into this code chunk. So I think I copied something. There it is. I'm just going to follow this example. So we've got total cigarettes smoked, but this is the log2 version, and that's going to equal log2 of total cigarettes smoked. Okay, I didn't really need that example around, but that will create, let's see, that was left over. Alright, so now we've got the variable, oh, that was weird, I pressed tab and it, okay. Alright, so now we have got a version of this variable, and as soon as this finishes running below, I'm going to run this piece of code which will create this new variable. Okay, that finished. Okay, so let's take a look. So now in the structure of the NESARC sub, we now have this new variable, total cigarettes smoked on the log2 scale. And you'll see that the values here are negative infinity. So that's not a great value to have in the data set. When you calculate with negative infinity, you don't get good results. So what we need to do, well, we don't really need to, but what would be nice to do is anything that's a 0 here for total cigarettes smoked, just to set that to not available in NA. When we focus on people who are smoking, we should really just focus on smokers and not worry about the people who are not smoking. That's my opinion. So let's change our mutate statement a little bit to account for that. That's up here. Okay, so let's make a modification. And we can use the if-else statement to do this. So we can do, for example, if-else, if total cigarettes smoked is greater than 0, then calculate the log2, otherwise put an NA. Now let me run this line of this chunk of code and look at the structure one more time. So now wherever cigarettes smoked equals 0, we now, for the log2, have NAs. And we don't see values here yet, but for values that were greater than 0, those will be on the log2 scale. So I'm quite confident that that's going to work. So we've created the variable that we need. It's possible that you didn't need this step, but it's quite likely that you didn't create that log variable. Okay, so now I'll scroll back down, and I'm going to now update this plot to account for our new situation. We don't need to restrict our data set anymore to cigarette smoke greater than 0. It will automatically ignore all the NAs. You can't plot NAs. And our total cigarettes smoked is on the log2 scale. That's that. And we can remove the logging of the axis. The Y variable now is log2 of total cigarettes smoked. And so now we can also say log2 cigarettes smoked versus age is a title. And the rest of this looks pretty good. We'll need to print the plot. And I just kept this as P3. You can keep it as P3, or you can rename this. It's not really in a sequence of plots anymore, so might as well take the P3 out of there. Let's make our plotting area a little bit larger, and then we will make a new plot. And of course, when you resize a plot that has 43,000 points 4 times, it takes a little time to replot it, which is what we're waiting for right now. And as soon as this finishes, I'm just going to clear it. Probably won't clear it until it finishes plotting. Right, we'll be patient. I don't know why my RStudio window keeps moving over. It doesn't want to stay in my recording box on my screen. Okay, then we've got here we go. All right, let's take a look. And that's what our plot looked like before, basically. Age, except this was on the log 10 scale. This is now on log 2. So every value is 2 to the power something. So a 3 here is 2 to the power 3, which is 2 times 2 times 2, which is 8. 6 is 16, 32, 64 cigarettes. Okay, etc. And that's per month. I know 10 would be 1024. So 9 is 512. 12 is, I don't know, no one can smoke that much. All right, anyway, so we got a plot. The next thing we need to do is calculate the correlation. Okay, so I'm going to put a little more space in here. You know, I'm going to do one more thing. I'm going to modify the size of this, the way this plot is going to come out. So I'm going up to the first code chunk where I've got some options where I modify the figure height and width. I set the default height and width for all plots, and I'm going to put that in the top of the code chunk so that I think this plot would look a little better if it was roughly square. So I'm going to put, say, 5 inches square. All right. As a small detail, it doesn't matter that much. All right, so let's go calculate the correlation now. Recall, in a previous assignment, in fact, I now don't remember. I'm asking you to recall, and I don't recall, whether that calculation was in the HTML file already. Here we go. So I went to the correlation assignment, class 13, and core of 2 variables. I'm going to do the simple calculation using the base R functions and not using tidyverse syntax because it's going to be much simpler. Okay, so I've copied the function there. I've saved myself typing COR. Okay, so the I'm going to calculate the correlation between age and total cigarettes smoked. And you need to specify that it's NESARC sub $age, comma, NESARC sub $total cigarette smoked log 2. Now this isn't going to work. Okay, I get an NA. And the reason I get an NA is because there are some missing values in the data set. There are some NAs. In particular, in log 2, there's a whole bunch of missing values. So the way to fix this is you can always look for the help by doing question mark and typing the function name. Let me clear my plot here so I can move these windows quickly. So the core function is in the stats package, which is automatically loaded when you start R. And in the core function, there's a option called use. Use equals everything. Okay, so let's go down and look at the use option. This is an optional character vector string giving a method for computing covariances on the presence of missing values. Good. This must be one of these, either everything, which is all values. So if you have any NAs in there, the whole thing just becomes NA. All observation, I think, is the same, but I don't know what the difference of those two things are. Probably the details is going to, yeah, so use, there it describes the details down here. So the one that we want, I guess I can point to it down here, is either pairwise complete observations or complete observations. That's going to, it says, if uses complete observations, then missing values are handled by case-wise deletion. So you remove all the missing values, and then you compute the correlation for what's left over. Okay, so use equals complete observations. I'm going to store that in an object called core AC, A for age, C for cigarettes, and that's 0.137. That's my correlation. All right, great. So now I've come down to the interpretation part. All right, sorry about this. Add another window. Oh, that's weird. Okay. All right, so let's type the interpretation, and I'm going to use this object in my writing. So I'll say the correlation is that. Okay, so the correlation is, I've put a left tick mark, a beginning and end. I've put the letter R, which means that the next statement will be interpreted by the R language. Put a space, and then the rest of this is a command that will be calculated. So that's just like if you run it in the console. It takes this value, passes it to the significance function, and I'm going to truncate at 3 significant digits. So 1, 3, and 8. Or maybe it rounds at 3 significant digits. Okay, so the correlation is that. So now we're going to interpret what this means. This is a positive, right? So the sign is positive. We saw that the plot showed a regression line that was upward sloping. This is a positive. I'll say this is a moderately weak linear relationship. Recall that correlation only deals with linear relationships, not any relationship. And the term moderately weak, oh, it's tough. How do you choose words to describe the strength of correlations? 0 is no correlation. 1 is perfect correlation. How do you describe weak, moderate, and strong between 0 and 1, or 0 and -1? It depends also on the context, right? So if you're an engineer or a physicist and you're making very precise predictions for a system that you can control, perhaps a 0.8 could be a weak correlation in your scenario. Whereas if you're in biology, where you can't control anything, then you know, 0.2 could be a strong correlation. Really depends on the context. Anyway, so this is a positive, moderately weak correlation, linear relationship. Maybe I'll just say, like, maybe to give some rough language, how about, you know, anything that's 0 to 0.05 is basically no correlation. From 0.05, okay, so from 0 to 0.05 is no correlation. If maybe a weak correlation would be up to, say, 0.15. Maybe a moderate correlation could be all the way up to, say, 0.3 or 0.35 or something. And then anything greater than that could be fairly strong, I guess. Up to, I don't know, 0.7, and then, like, awesome. Something like that. Okay. Don't quote me on that. I'm just sort of helping you give a bit of language. All right, so I haven't quite finished the interpretation. So the correlation is 0.138. This is a positive, moderately weak linear relationship, and then say what it's a relationship between age and, now the interpretation here only works for log 2, because our linear relationship is on the log 2 scale, not on the original scale. Anyway, so log 2 of total, we don't really need all these capital letters, total cigarettes smoked per month. There we go. Something like that would be pretty good. Now, if you have a correlation that's really weak, that's okay. There's no, you don't get extra points for getting, like, awesome results. You get points for presenting the data accurately and interpreting it accurately. All right, so that's the first part of the assignment. I think it's probably a good idea to cut this video into 2 pieces. So I'm going to stop here, and I'll come back to work on the contingency table. Let me take a moment just to knit this and see that this sentence and the plot have come out in a way that we're happy with. So if you want to scroll 20 seconds into the future, hopefully this will be done knitting by then. I will go to the other window and open it in the browser and scroll down to class 15, correlation. And this is still the old version, which is why there's nothing, no results in here. Once RStudio finishes, I'll refresh that page, and we'll be able to take a look. In fact, let's do this. That does take a long time to plot. I bet this all these extra plots, we don't really need that anymore. I'm going to disable this in the logarithm section. This other set of all these plots, don't really need this anymore. That's already been graded. I'm going to disable that. Let's take a look if there's any other big plots. I don't know. There's a couple. Maybe I'll disable these too. These are all plots that are plotting points. And whenever you plot points, when there's 40,000 of them, it takes a long, long time. This is a bar plot. That's not going to take long. Box plot. Geom jitter, that could take a little while. Okay, so I'm disabling quite a number of plots here, only because we don't need them at the moment. The code's here in case we need to enable them again. Histogram won't take very long. Oh, but you know what does take a long time with histograms? Okay, I've already disabled it. A line here, geom rug. A rug is, it puts little tick marks under the x-axis wherever the actual values are, and there would be 40,000 of those little tick marks. So that could take a long time. Bar plots are very quick. I think that's pretty good. So next time I knit this, it should finish in 15 seconds. All right. Anyway, so that's finished. Let's refresh the page. Okay. Here's what we just did. We put our plot in there, and we labeled the axes, and then we calculated the correlation and said the correlation is 0.138. This is a positive, moderately weak linear relationship between age and log 2 total cigarette smoke per month. That looks pretty good. Let's go to the rubric and grade ourselves. With your previous or new bivariate scatter plot, calculate the correlation. So the plot is repeated. We did that. We calculated the correlation and we interpreted it. Cool. All that effort, and we got 4 points for it. Congratulations. All right, we'll come back and do the second half of this video in a moment.